Okay, so we're going to look at problem number 8 now. Move this for now. So they give us this data and they give us in decades, and they label the decades and the number of hurricanes striking. They want us to draw a scatter diagram. Which of the following shows the correct scatter diagram of this data? You should be able to match up these points. They tell you this is our X and this is our Y, or H, and they even label the axis H. So we have 8, 8, and 7, 8. So our last two are both going to be the same. Which relation best describes these data? Thinking of our graphs from the previous chapter. Is it linear? No, it's not a straight line, so it's neither of these. Is it cubic, or does it have no relation? It looks like it's following the line of a Kirby line. So this one is actually cubic. No relation is just your crazy scatter plot you see where nothing goes together. Then they give us a formula. I don't know if this formula is the same for everyone or not. Use a graphing utility to verify that this is the cubic function of best fit. Use this function to predict the number of major hurricanes that struck between 1961 and 1970. So we can go back up to our data here.
I'm just going to let you know that I'm coming over that way.
So you can plug the 5 into this and work it out, or you can literally just do what they said and use it. At least it's worked for mine so far. With a graphing utility, draw a scatter plot of the data, the best fit of the scatter diagram. So that we know this is cubic, so we know it's going to have that curve in it like the cubic function. So you don't have to have a graphing calculator for this, although Texas Instruments is having their thing if you didn't see that. So go with the one that looks like the cubic function. Concern has risen about the increase in the number of intensity of hurricanes, but some scientists believe this is just a natural fluctuation that could last another decade or two. Use the model to predict the number of major hurricanes that will strike between 2001 and 2010. So that would be decade 9 using this. So we're going to take this equation they gave us, plug 9 into it to find the answer. So instead of X, we're putting 9 inside. 0.159 times 9 cubed, subtract 2.32 times 9 squared, plus 9.33 times 9 plus 0.786 equals, and they tell us to round it to the nearest integer, so 12.747 would round up to 13. Do you believe your result appears to agree with what the scientists believe? So I'd look at my chart, and the scientists believe that it's a natural fluctuation. 13 has been there before, so it's going to be yes, because it's comparable. This one says comparable, where this one says it's considerably higher. So just pay attention to that. There's a 13 on it, so it's not considerably higher. From your 2001, 2005, 6 hurricane strike, does this support or contradict? So since this is 13, that would be half the decade. 13 divided by 2 is going to be like 6.5, so this would support ours. My other one I did previously was 12, so it both supported it in it, but if you get one that says like 8 and they say 6, it wouldn't support it. All right, continuing on. So number 9, analyze the polynomial function f of x equals x cubed plus x squared subtract 2x. So before I hint first factor, this is always the first term, so the graph of f behaves like x cubed. our x-intercepts this, we're going to have to factor for our x, our y, we probably don't have to factor it for. But here we go. So we're factoring this. So we have x cubed plus x squared subtract 2x. I can factor an x out of all of them, so I'd have x squared plus x subtract 2. So I'd have positive 2, negative 1. So x times x plus 2 times x minus 1. And then check it, x squared subtract x plus 2x subtract 2. All right. So when we go to find our y-intercepts, we have, I don't want to write it here. 0 equals x, 0 equals x plus 2, and 0 equals x minus 1. So we'd have 0, this one would be negative 2, and this one would be positive 1. So 0, negative 2, and 1. Y-intercepts, so we have y equals 0 times 0 plus 2 times 0 minus 1. Anything times 0 is 0, because we have 0 times negative 1. The zeros are the same as our x-intercepts, so we have negative 2, 0, and 1. I put them in order that time because they have us do the smallest, middle, and largest. So let's look at these. 1, 1, 1. So the multiplicity of all of these is 1. So 1, 1, 1. So they're all going to cross because it's odd. And then we have negative 2, 0, and 1. Determine the maximum number of turning points. 3 subtract 1 is 2. It's positive, so we're going to be going up at the end of this, so it's not this one or this one. And then we're crossing at negative 2, 0, and 1. So these both have 0. This doesn't really, it only crosses at 0. So negative 2, 0, 1. All right, last problem on this one. I'll work that one and put it on there. I didn't work out 6 and 7 because they just were the same as 5, so I didn't want to do more of them. All right, analyze the polynomial. The graph behaves like y equals, and it's the first term, so 3x to the 4th. We have to factor this. Okay. So let's see, we have 3x to the 4th plus 21x cubed, subtract 12x, subtract 84x. I can factor out a 3x. So we have x cubed plus 7x squared, subtract 4x. 84 divided by 3, 28. We're going to factor that by grouping now. So we have 3x in here because I'm going to factor this group and this group. So I'm going to have x squared times x plus 7. And there's subtract here. I'm going to factor out this negative. And I'd have x plus 7 here. Double check. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. So I'd have x squared minus 4 times x plus 7. And this is times 3x. I can keep going because I can factor out this x squared minus 4 because it's the difference of two squares. I'm just going to run out of room. So you have 3x, x minus 2 times x plus 2 times x plus 7. Yay. All right. Our x-intercepts, that's when y equals 0. So 3x equals 0 equals 3x would be 0 equals x. We have 0 equals x minus 2, so we'd have 2 equals x. And we have 0 equals x plus 2, so negative 2 equals x. We have 0 equals x plus 7, so negative 7 equals x. Okay, so I'm around in order. Negative 7, negative 2, 0, and 2. Y-intercepts. If I put 0 into this, they'd all have a 0 with it, so the only y-intercept is 0. Hope that doesn't bother anyone. The zeros are the same as the x-intercepts, so we have negative 7, negative 2, 0, and 2. All of these have a multiplicity of 1, so, how'd they write this? When the zeros are counted, the first 0 is a multiplicity of 1. So the graph crosses the axis at x equals negative 7. They just say first, second, third, fourth. They don't. I hope they're wanting us to go from least to greatest like they had in the previous ones, but it would surprise me if not. Cross at negative 2, multiplicity 1, cross at 0, multiplicity 1, cross positive 2. Turning points, 4 subtract 1 is 3. It was positive 3x to the fourth, so we're going to have a positive graph. And this one is negative, and this one is negative. So let's see, we need to cross at negative 7, negative 2, 0, and 2. They both cross at 0, but we have negative 7 and negative 2 here. Oh my gosh, how long have y'all? So I was saying these both are negative because they open up to the bottom. And then this one had the negative 7 and the negative 2, where this one just had negative 2 and positive 7. So, yeah. Stop this one.